Hello and welcome to Maths with Jacob. This lesson will focus on irrational numbers. Irrational numbers are very special numbers because they cannot be expressed in the form P over Q, where P and Q are whole numbers. The most common and widely used irrational numbers are surds, which contain square roots, cube roots, etc. With respect to these types of numbers, we have an exact fraction or decimal equivalent cannot be obtained for irrational numbers that contain surds. Hence, any final answer involving these types of numbers must remain in the surd form. Let's look at some examples of irrational numbers. The square root of 2 is a surd. If you wanted to approximate the value, that's what you get. And it continues on forever and there's no set pattern. We can see that the square root of 2 is neither a terminating decimal nor a repeating decimal. No pattern is obvious, hence the square root of 2 is an irrational number. In a similar manner, the square root of 7 can be approximated to this number here, continues on forever, no set pattern. We can see that the square root of 7 is neither a terminating decimal nor a repeating decimal. No pattern is obvious, hence the square root of 7 is an irrational number. 3 times the square root of 5, which is 3 times that approximation, which is that approximation there. It continues on forever. We can see that 3 the square root of 5 is neither a terminating decimal nor a repeating decimal. No pattern is obvious, hence 3 the square root of 5 is an irrational number, and there are many more examples. Another very famous and well-known irrational number in the field of mathematics is pi. This is the symbol for pi. You'll see that a lot in your future years. This very important number is used to help us find the area and circumference of a circle, once we know the radius or diameter. For pi, the digits after the decimal point continue on forever and have no set pattern. So there's an example. This is just an approximation here. They continue on forever. We can see that pi is neither a terminating decimal nor a repeating decimal. No pattern is obvious, hence pi is an irrational number. For practical purposes, we can approximate the value of pi to 3.142 or 22 over 7. These values enable us to obtain very good approximations for the area and perimeter of any given circle. So this video has introduced the idea of irrational numbers, and we've given some examples of the square root of particular numbers, and we've seen how they are irrational because the decimal point continues on forever, the digits after the decimal point continue on forever, and there's no set pattern. And we've also seen the very famous irrational number known as pi, which is used for calculations involving different measurements for the circle, in particular the circumference and area.